Welcome all. Now I am going to discuss question number 53 from the GATE 2018 paper Electrical Engineering. The question is, a DC to DC converter shown in the figure is charging a battery bank B2 whose voltage is constant at 150 volts. B1 is another battery whose voltage is constant at 50 volts. The value of the inductor L is 5 millihenry and the ideal switch S is operated with a switching frequency of 5 kHz with a duty ratio of 0.4. Once the circuit has attained steady state and assuming the diode D to be ideal, the power transferred from B1 to B2 in watts. To know the concept of and detailed analysis of buck boost converter, audience can go through the given NPTEL video link. Let us discuss some useful information to solve the problem. Here, when the switch is closed, the current loop is like this. So, the IL current through the inductor rises. So, current through the inductor rises and also Vs is equal to VL. So, voltage across the inductor is equal to the voltage across the source till the switch is closed. During this time period, current through the capacitor supplies to the battery. So, current through the capacitor is constant and the voltage across the capacitor is decreases. So, voltage across the capacitor is decreases and it is linear over time period T. Here, load voltage and the capacitor voltage are same since these two are parallel. Now, when the switch is open, inductor now going to discharge because till previous period when the switch was closed, inductor charges. When the switch is open, inductor will discharge. So, the current through the inductor decreases linearly over time period when the switch is open or off, and voltage across the VL is equal to the V0 minus Vs whole minus of. It is the voltage across the inductor is the negative of the V0 minus Vs. So, the voltage across the capacitor is rises when the switch is open. This is the explanation. Using this information, let us solve the problem. Given data, given it is B2 is at 150 volts and B1 is at 50 volts and the value of the inductor it is 5 millihenry. All the switches are ideal and the switching frequency F is equal to 5 kHz and the duty ratio D is equal to 0.4. So, what we need to find out is power transferred from B1 to B2 we need to find out. So, this is boost converter. Boost converter means the voltage relation between V0 and Vin is like this. V0 by Vin is equal to 1 by 1 minus D. We know the output voltage V0 is equal to 150 volts. Input voltage also we know that is 50 volts. So, we need to find out the duty ratio of the switch, that is D is equal to 0.66. Based on the input and output voltages, we found out D of the circuit. D of the circuit is, duty ratio of the circuit is 0.66. But the given duty ratio, operated duty ratio is 0.4. D given is this thing. So, this is the boost converter working in discontinuous mode. Boost converter working in discontinuous mode, since the circuit duty ratio is less than the operated or given duty ratio. So, what we need to find out is, how much time the circuit is in discontinuous mode. We need to find out. So, that is how much time the circuit is in discontinuous mode. We need to find out. That thing we will denote it with beta. So, switching time period is, we need to find out, that is T is equal to 1 by switching frequency, that is equal to 1 by 5 kilohertz, that is 200 microseconds. So, the time period, total how much time period the switch is on is equal to duty ratio into T. So, D is how much, given it is how much, operated one, that is 0.4. This is D operated. 0.4 into 200, that is 80 microseconds. This is depends on the value of the duty cycle given in the question. But then we need to find out the beta value. That beta value is given as V0 is equal to beta by beta minus duty ratio into Vs. Duty ratio is how much? 0.4, right? Because circuit is operating at 0.4. So, V0 is 150 is equal to beta by beta minus D is 0.4 into 50, implies beta is equal to 0.6. This much of time period the circuit is in discontinuous mode, means it is not conducting, current is not flowing. So, we need to find out the value of Vs. Vs is equal to L into di by dt. Di means delta I, the difference of the maximum and the minimum current flowing through the inductor. Inductor is charging like this, right? Charging during the on period, and then it is discharging during the off period. This is the, we can say I max, this magnitude, and this magnitude as I min, and this difference is the delta I, that is di we represented. So, this dt is, we can say T on period. This area we are finding out. This is the area we are finding out. That is L is how much? 5 millihenry into delta I, that thing we need to find out, divided by T on, just now we found out, that is 80 microseconds. which implies Vs is how much? Source voltage 50, which implies delta I is equal to 0.8 amperes. And we know that since the circuit is in discontinuous mode, right? And we have told that delta I is equal to magnitude difference of the I max minus I min. Since circuit is in discontinuous mode, I min has to be 0. So delta I is equal to I max, that is equal to 0.8 amperes. So we need to find out the average current flowing through the inductor. Average current flowing through the inductor is area of the triangle actually. That area of the triangle is 1 by 2 into height into width, right? Triangle area is, height is how much? I max into width is how much time it has on divided by the total time period, that is equal to the 1 by 2 into 0.8 into beta is 0.6 into t is 200 microseconds we found out, divided by 200 into 10 to the power of minus 6. So if we simplify, we will get this thing as 0.24 amps. So power transferred from battery B1 to B2 is, power transferred from B1 to B2 is B1 voltage, that is V in, into average current flowing through the inductor, that is 50 into 0.24, that is 12 watts. So the power transferred from B1 to B2 is 12 watts. So the power transferred from B1 to B2 is 12 watts. Thank you.